Hello, welcome. Join me as we provide answer to this question I found in my inbox, a strange looking logarithm. So we have log 8 base 4 plus log 128 base 2 minus 20 log 2 base 4, all divided by log 16 base 4 minus log 8 base 4. You can see the numerator consists of two different bases. So let's see how we can manipulate this. So now let's repeat the question. Take your time. Let's see how we can break it. Now you can see we have base 4 base 2 base 4 base 2, and this right here is in base 4. It will be difficult to change this to become 4, but it is easier for us to change 4 to become 2, as in 2 exponent 2 give us 4. So we can easily change the bases or simplify the base 4 to become base 8, base 2. So let's see how we can do that. That means I'll be having the log of 8 base 2 exponent 2 plus the log of 128 base 2, 20, the log of 2 base 2 exponent 2. Then all this will be divided by log 16 base 2 exponent 2 minus log 8 base 2 exponent 2. This is going to be a long procedure, so let's follow through. Pay attention. So now, if we take a logarithm that have, let's say, the logarithm of a base b exponent n, what happens is that we send the exponent. The exponent here comes to divide whatever is at the back of the logarithm. So if in this case there is nothing, meaning there is 1, meaning the exponent here comes to become a fraction to multiply. So this is going to be the reciprocal of the exponent comes to multiply here. Meaning I will be multiplying here by the reciprocal of 2, which will be 1 over 2. Here 1 over 2. Here 1 over 2 in all the cases. So simply put, here becomes 1 out of 2 the log of 8 base 2 plus log of 128 base 2 minus 20 divided by 2 log of 2 base 2. Then all this will still be divided by half log 16 base 2 half log 8 base 2, right? Okay, so now that we are done with that, what do you think we can do again? Right here is going to be 10, meaning 20 divided by 2 will be 10. So now I have the same base 2 base 2 base 2, and you can agree that if they are in the same base and we are having addition, we only multiply the argument. All right. And when I have a number multiplying a logarithm, that could also become the exponent. Meaning here is now going to mean, if I send this to become an exponent, we know 8 exponent half is the same as the square root of 8 in terms of indices. So let's introduce that here, meaning the log of the square root of 8 base 2 plus the log of 128 base 2 minus, this is going to be 10 and also goes to be an exponent. So log 2 exponent 10 base 2. I believe you get this one. This is 10, which is multiplying a logarithm. So it will now go to be an exponent of the number. All right, let's maintain this as log of root 16 base 2 minus the log of root 8 base 2. I believe we are making headway, right? Slowly. What do we do? Let's employ the principles of multiplication. As I'm adding, I multiply. As I'm subtracting the values, I will perform division. Meaning if I have log of A plus log of b minus the log of c if they are all in the same base, meaning the argument to multiply as log a times b divided by c, since they are all in the same base. So the argument becomes multiplication and division. So I can perform the same here, meaning this is multiplying this divided by this in the numerator. Then I can also perform the division as in the case of what? The denominator, meaning this is subtraction. It becomes the root of 16 divided by the root of what? 8. If they are all in the same base, base 2, base 2. Then we can also employ the principles of set under properties. If I have a root of 16 divided by the root of 8, I can put all under the same umbrella as 16 divided by 8. One property of division in set. So that 16 divided by 8 will give us 2 as root 2. You can perform this as root 16 as 4 divided by this, and you do rationalization. You arrive at the same answer. So let's put all that you said into calculation as the log of 128, the root of 8 divided by, let's just say we have 2 exponent 10 base 2 divided by the log of root 2 exponent 2. Maybe I am jumping before the gun, so let's just put it this way. The root of 16 divided by the root of 8. I believe that will be easy to digest. The rule is this argument minus this. So therefore, the argument divided by the argument. So root 16 divided by root 8, still under the same base, base 2. So here, let's simplify this as the log of 128 root 8 divided by 2 exponent 10 will be 1024 base 2 divided by this, which will now be the log of the root of 16 divided by 8 base 2. I believe you are with me slowly as we are moving. So this, we use this 128 to multiply the root, not multiplying the 8, because this is not under the square root. So this is rational, this is irrational. Okay, so from here, let's see how we are going to transfer this into this side, knowing very well that 128 has a factor here. So this is going to be 128 goes there 1 and goes here 8 times. Don't forget, this is 2 exponent 7, this is 2 exponent 10. So we can get the remainder of 2 exponent 3, which is 8. So meaning I'm having root 8 over 8 in there. So the log of the root of 8 divided by 8 base 2 divided by, this will divide this to give you 2. Therefore, I have the log of root 2 base 2. I believe you are taking your time with me slowly as we go. Then we are now having the logarithm of the same base with different arguments. If I like, I can also simplify the root of 8, which we know will be root 4 times 2. If you separate that, it gives you root 4, the root 2. A root of 4 give us 2, meaning this is 2 root of 2. A root 8 is this. So I can do the same thing here as in the root of 2 out of 8 root 2. You look at that, the whole of this divided by 8 is the same as taking the rational divided by the rational, then the root will multiply. Still base 2, all on the root of 2, the log of root 2, base 2. Now what do we do? I think we can simplify. This will go here 4 times. So let's see how we can do that. Meaning I'll be having the logarithm of 1 out of 4, the root of 2 base 2 divided by the log of root 2 base 2. I believe you can agree that we have what they call change of base. If I have log A base B, I can rewrite this using a different base. This is the base B. So it becomes the log of the base n, the number A, divided by the log of B, the base is n. I'm having change of base. The base is B. I want to change it to become base n. Do you see the same thing here? That I'm having the base to be n. I'm having the argument, an argument. So I can easily write this as the log of the base, ignoring the 2. So that I can take this as my B. You know, B become the base. The A still remain as the argument. So here, let me see if I can write it here. The log of this is going to mean I have root of 2 out of 4, as in this case. The base, let me clean here. The base will now be root 2. Do you agree with that? Now the base 2 is taken away. This is what we change the base to become, the argument. Don't forget, 1 over 4 root 2 is the same as root 2 over 4. Alright, so this is the argument right from here, ignoring the base, picking the argument here to become a base. I believe you get that easily. Alright, if that is true, then we can move from here, changing the square root now to become a power of half, right? So if we are going to do that, I can write that as the log of root 2 out of 4, 2 as the base, exponent of half, right? And remember we said when we have exponent as a base, we find the reciprocal of the exponent to multiply the logarithm. So the reciprocal of 1 over 2, it will be 2 over 1, which is the same as what? 2. Meaning this 2 goes to multiply the log of root 2 over 4. Then we have this. I don't know if you are getting it. Right from here, this is taking a reciprocal to multiply the logarithm. We have not done anything to the argument. We are only simplifying the base, which has a square root, a power of half, now become without a power, which is power 1. So what do? We still have to employ the principles of the third law. Any number that multiply the log become a power of the argument, right? So if that is the case, I am going to say that I will be having the log of the root of 2 out of 4 all square base 2. Can I write that? That this is becoming the power. Don't forget, this is the argument. It's already a fraction. So the fraction square. The law of indices, A over B all square is the same as A square, B square. The law of indices, or the properties under indices. Which means I can easily square the top to mean log of root 2 all square divided by 4 square, the base 2. And in that case, square root of 2 square, the square root cancel. So I'll be left with the logarithm of 2 divided by 16 base 2. 4 raised to the power 2 is 16. We can reduce that in the argument. 2 go here 1, 2 go here 8. So log of 1 out of 8 base 2. Which I can still write this as indices, right? Indices with exponent of negative because of that. If you have a exponent, this is the same as 1 over a positive exponent. So this is having 1 there. Because of the 1, we change to become negative. So this will now be written as log of 8 exponent negative 1 base 2. I am seeing base 2 here, meaning I can also express 8 in terms of what? Base 2. Meaning log of 2 exponent 3 give me 8. But there's an exponent of half and negative 1 there. Let's introduce that. And the law of indices, a exponent n b, meaning it become a n times b, the two multiply together. So we can rewrite this again as log of 2 exponent minus 3 base 2. Is that not it? Let's go back to the third law of indices. A power comes to multiply the log, meaning negative 3 will multiply log of 2 base 2. Are you seeing what I'm saying? That a logarithm of a number of the same base is 1. So log 2 base 2 will give us 1. Meaning this becomes negative 3 times 1. So at the end, our answer is just going to be negative 3. I believe you did not blink an eye from the beginning, following the step by step. If you really find this interesting and educative, don't forget to share it. Don't forget to subscribe to the channel. Click on the notification bell in the YouTube in order to receive alert anytime a new video such as this is uploaded. Thank you for watching. Bye bye.